Good afternoon, good evening, good morning, whenever time of the day you're watching this. I hope you are well and all is well with you and your family. Welcome back to Making Math Make Sense. I am going to be going over another video, or I'm doing another video that is going to help you prepare for the June 2026 Regents exam, or whenever you're taking the Regents, whether it's January 2027, June or June 2027, August 2027, August 2026, whenever. I think this is going to help you. The topics that we're going to cover today are finding missing side lengths in similar triangles, finding missing angle measures in right triangles, applying the sector area and arc length formula, finding the area of a non-right triangle, and finding the volume of different 3D shapes. Now, I want to talk about finding missing side lengths in similar triangles. So there's some things you need to look out for. First off, you should know if two triangles are similar. Like, they're similar by either SSS, SAS, or angle, right? And now it is recommended to draw the triangle separately in the same position. It's not a requirement, but I think it's going to help. Look for which angles are congruent, right? And that's sometimes going to be embedded in the question. Parallel lines often is an indicator that there's congruent angle somewhere. Perpendicular lines means that there's a 90-degree angle. So if two triangles are similar, the corresponding angles must be congruent. Pay attention to the order of the letters. I think that's super important. So for instance, if triangle ABC is similar to triangle DEF, this means that the triangles are similar, which means that angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. You have to pay attention to the order of the letters, right? That's super important. And then AB is proportional, not congruent, proportional to DE. So we could put it as almost like a scale factor, AB being divided by DE, or DE being divided by AB. And then BC is proportional to EF, and AC is proportional to DF. All right. So with that said, let's get into the next question. Right triangle. So they're automatically telling you that is a right triangle. ABC. Point D is on AB, and point E is on CB, such that this line is parallel to this line. So you should automatically start thinking about the relationship. If you have two lines that are parallel, you should remember or know that this angle would be congruent to this angle, right? These are corresponding angles. So similarly, this angle would be congruent to this angle. And we already know this is a right angle. So as a result, this has to be a right angle too, because they're corresponding. So as a result of this being true, we can say triangle A, B, C is similar to triangle D, B, E by angle. If you weren't able to kind of make that conclusion, it's okay, but that's the hidden content in this question that would allow you to do what we're about to do. So they said, and I would encourage you also to draw the triangle separately. So we have triangle ABC. I'm not drawing it to scale. And we have triangle DBE. We know that AB is 15, so I can put 15 right here. And I'm going to put it for this as well. This whole line is 15. We know that BC is 12. This entire line is 12. So I'm going to put it right here. And now we also know that EC, that's the tricky part. EC, which is this line, is 7. So if this entire line is 12 and this part is 7, you should have the reasoning, or you should be able to make the connection that this part would be 5. And that's the tricky part. So you have to realize that, oh, that must be 5. And now we're looking for the length of BD, and we're also looking for the measure of angle BDE, which is this angle. So we could put a little question mark right here, and we could also put maybe X right here, right? So since these two triangles are similar, this means similar, we can now set up a proportion. So 15 corresponds to X. So we could do one triangle at a time. So 15 over 12. And then since 15 matches up with X, that has to go on the top, and 5 would go on the bottom. So now if we cross multiply, we're going to get 75 equals to 12X. And now if we divide by 12 on both sides, we're going to get the answer of 6.25. Now, they said round to the nearest integer, so that would lead us to 6. All right. If hypothetically you said 6.25, it's not the end of the world. And to be quite frank, this was a question that came up on the previous Regents exam. And this was a multiple choice question, and they had this 6.25 as the answer. If it's a short response, I'm not too sure if they'll say round it to the nearest integer. I don't know, right? But if they did, it would be 6. So I just modified the question. So it's a short response, and I also added the layer of finding the degree. So now we know this is 6.25. Let's just use that for now, and we'll round in the end. This angle is what we're looking for. Since it's a right triangle, this is the opposite of that angle, and this is the hypotenuse. So as a result, thinking about so, ka, toa, this is a O, by the way, I would encourage you to write this down. If you haven't, please pause the video so that you can catch up and process what's happening. So since we are looking for the angle that's related to the opposite side and the hypotenuse, we have to use sin, specifically sin -1. And if you put that in the calculator, sin -1, and here I use 6, but you could definitely use 6.25. In fact, you should use 6.25. And if you put that in the calculator, let's go ahead and do it. So I'm gonna go to on, go to new, no, add calculator. And I'm gonna put instead of the regular sin, say -1, 5 over 6.25, and I get 53.1301. So if you round that, right? So if you use 5 over 6.25, you're gonna get an answer of about 53. Right. So that would be your answer. If you were to put 5 over 6, that would be your answer. So again, I'm not too concerned about the rounding for this situation. I'm more so concerned about you getting the proportion correct. 15 over 12 equals to X over 5. If you were able to kind of make that connection and get to that point, that's great. And then knowing that this is a right triangle, and then finding this angle using the fact that this is a right triangle. All right, so I hope that was helpful. We're going to go ahead and go into the next question, which is related to sector area and arc length. Excuse me. Usually they ask about one. Here, I'm asking for both. I'm asking for the length of AB, and I'm asking for the area of sector AOB. So you have to know two different formulas, right? And I know this is supposed to say delta, all right? For those of you, very observant. Area for a sector is equal to the central angle divided by 360 times pi r squared. All right, so if you didn't know that, please make a note. For arc length is slightly different. Arc length is basically the same initial thing, so is the central angle divided by 360 times 2 pi r. All right, so with that said, we're gonna set up the formula. It'll be 140 over 360 times pi, and then we know the radius is 8 squared. All right, this is the radius. Is coming from the center of the circle and going to the edge of the circle. That's called the radius. And this angle, since it's in the center of the circle, this is known as the central angle. All right. Now we're basically going to use a calculator. Now notice they said leave it in terms of pi. So basically you're going to put everything in a calculator except for pi. Don't put in the calculator. If they say in terms of pi, don't put in calculator. Right? So you're going to write your answer in the end as a fraction or decimal and then pi. And then the same thing for this one. You're going to do 140 divided by 360, but you're going to multiply 2 by pi by 8. And you're literally going to put that in a calculator, and that is basically your answer. So one is going to be one thing, and the other one is going to be a different value, but they're both going to have pi in the end. All right, so it's going to be something pi and something pi, and you're done. So basically you're putting this times 2 times 8. So I'm going to just box and circle what you're going to be putting in the calculator. 140 times 2 times 8, and then 140 divided by 360 times 8 squared. You're putting those two things in the calculator only. All right, and then that would lead to your answer. All right, so we're going to get into the next question. This is related to area, but for triangle. So you need to know this formula, and I know it's a lot of formulas to remember, but you can commit and you could process and you could remember anything you commit you commit to, right? Like anything that you put your mind to, you can do. So I need you to just lock in, write some notes, do flashcards, whatever you need to do. You can memorize this stuff, but it's you have to put in the work, right? So 1/2 AB sin C. This is the formula for the area of any triangle. It doesn't matter what triangle it is. It could be a right triangle, a scalene triangle. It doesn't matter. Anytime you're being asked to find the area of a triangle, this is the formula you can use. A and B represent the sides. And this is the angle in between the two sides. Angle in between the two sides. So I need you to remember that, right? You don't have to draw a diagram, but I recommend it. All right, so in this case, I'm going to draw a diagram. By the way, the answer to this is 42. So if you know how to do this already, skip this part of the video and keep it moving, right, to the next part. So A, and I'm sorry. So let's put exact values. I'm sorry. So we have T, I, A, and we know that TI is 8, and obviously is not drawn to scale. So AI is 12 and TA is 18. And the measure of angle I is 61. So notice we don't know any of the other angles. And we know that, but we know that angle I is 61, and the angle and the sides that create that angle are TI, right, and AI. So these two lines form this angle. So as a result, that's what's going to go inside of our formula. We're not going to entertain 18 because that's not related to the angle, or that's not connected to the angle or adjacent to the angle. So we have 8, and we have 12, and we have sin 61. We're literally going to put this in a calculator, and we're going to get approximately 42. They said round to the nearest integer. And by the way, the nearest integer is the nearest whole number, right? So, and that is pretty much it. All right. We are almost at the end, y'all. Thank you for bearing with me. We're going to do one more question and then with the finale for this. All right. In a different video. So you need to know the different formulas. It's so important for you to know the different formulas. So with that said, I'm actually gonna go to the formula sheet for a moment. So you need to know the different formulas that you have access to, and that is these, or that's these formulas. Cylinder, prism, sphere, cone, and pyramid. Notice how they don't give you the explicit formula. That's your job. You have to know the actual formulas. So the actual formulas are here. For a cone is 1/3 pi r to the second, pi r, 1/3 pi r squared h. Cylinder, pi r squared h. Pyramid, 1/3 length times width times height. And obviously it's a rectangular or square pyramid, right? If it's a triangular pyramid, that's slightly different. And for a sphere, it's 4/3 pi r to the third. Hemisphere, we went over that earlier or in a different video. And a prism, length times width times height. So with that said, we can apply these formulas accordingly. We know for a cylinder, V is equal to pi r squared times h. And you want to read the question carefully. They said diameter. That's not the radius. So you have to divide the diameter by 2 to get the radius, which is 6. So this is our radius and our height. So we're plugging in 6 inside the r, and we're plugging in. So for a prism, a square prism, length times width times height, even if it's for a rectangular prism, is the same thing. And now we have a base length. So the base of the prism is a square. If it was a rectangular prism, it will be a rectangle. So it will be 10 times 10 times 4. All right. And then for cone, we went over that. 1/3 pi r squared h. And again, diameter. So that means the radius is 9. 18 divided by 2. So that's going to be 1/3 pi 9 squared times 8. And then for the cylinder, I know I didn't show that, pi times 6 squared times 4. If you put these in a calculator, you're going to get an answer, and the answer is going to lead to the cone having the most space. So you have to actually show this work like I kind of modeled it, and then say cone in the end. All right, this is a 4-point question. So in addition to the work, you got to like write something. In this case, they're asking for which container has the most space. The answer, the cone. All right. Thank you guys for watching this. I know this was a little longer than my previous videos, but thank you for hanging in there. We're almost at the end. I got one more video for y'all, and then hopefully this will be enough to get y'all over the hump. All right. I appreciate y'all. Have a good day and continue to stay on the grind, right? Keep grinding, keep focused, keep doing your thing, keep doing your part, and everything else will fall into play. Have a good day.